Hey guys, welcome to your 1.6 notes on multiplying and dividing real numbers. Multiply and divide. When you think real numbers, just think normal numbers today. By the end of the day, you will be able to find products and quotients of real numbers. Now, to get our head in the game, let's notice some patterns, because that's really all mathematics is finding patterns. So, we start out 2 times 3 is 6, 2 times 2 is 4, 2 times 1 is 2, and we carry on down the line, but we should be able to notice a pattern here. I'll just do this. From 6 to 4 is minus 2. Actually, I should have gone the other way, huh? Yeah, I'm going to go the other way. So we have 0, negative 2, and negative 4. So starting up here, we're adding 2 each time, and each step is plus 2, plus 2, plus 2 every time. That's because we're essentially adding a new 2 to our category. A negative 2 plus 1 is negative 1, plus 1 is 0, plus 1, plus 1, plus 1. And that's why it's like counting all the 2's that we have. So each time we're adding another 2 to the pile. Plus 2, plus 2, plus 2. So when we go backwards, we're going to find the opposite way is true. Following this pattern over here, we have negative 2 times 3 is negative 6, negative 2 times 2 is negative 4, negative 2 times 1 is negative 2, 0, positive 2, and positive 4. Because when we're following this pattern up here, we're minusing 2 each time, because it's like we're adding another negative 2 to the pile each time. If you have negative 2, if you have one negative 2, you add another negative 2, add another negative 2. Now, the sign of the product of two positive numbers. I'm asking what happens when we multiply a positive times a positive. We can see that will be green because that's positive. We see two positives here, here, and here, and that's it. But those are all positive numbers. And then for a positive and a negative, so when we multiply a positive times a negative number, let's see, we have, I think I'll just do yellow for all that. That'll be easier. So when we have positive times negative together, we have that happen here, here, positive times negative. Well, negative times positive is the same thing as positive times negative. The answer there is always negative. And then finally, when you have the product of two negative numbers, if you have negative times a negative, we have that here, and we have that here. Those are both positive. Awesome. So basically, if their signs are the same, it's going to be positive. Signs are the same negative, it's also positive. And if their signs are different, they're negative. If you remember that, guys, that's the important thing of the lesson in the nutshell. We'll rephrase it later to make it neat, but hey, that's basically our key idea. Now I want you to consider the following. Consider that that multiplication is just addition over and over again. For example, let's start at 0. And then we're going to take 3 steps of negative 5. So to go down, negative 5 is like going here, all the way down to negative 5. And we're going to take that step 3 times. 1, 2, 3. Done. So 3 times negative 5 is negative 15. Oops, negative 15. It's the same thing as saying negative 5 plus negative 5 plus negative 5. Cool, huh? That's a fun fact for you. Alright, so multiplying real numbers. Just like above here when we said the product of two real numbers with different signs, that's always going to be negative. So 2 times negative 3 is negative 6, and negative 2 times positive 3 is negative 6. So let's go ahead and make a chart for you to help you remember that. So you have negative times a negative equals a positive. I had a former student who'd be like, well, negative times a negative is a positive. There you go. Oh, shoot. That's totally the wrong illustration. That's for later. Ha. Just kidding. Forget I said that. Okay, anyway. So negative times a positive is a negative, and also a positive times a negative is a negative. So there's your picture to help you remember that. Now, to look on the positive side of things, if you have two real numbers with the same sign, that will always be positive. For example, positive 2 times positive 3 is positive 6. Negative 2 times negative 3 is positive 6. So you can remember that by saying positive times a positive equals a positive, or a negative times a negative equals a positive. Like my former student liked to say, negative times a negative makes a positive. Cool. And then you would ask me, oh, Miss Van Dyke, are you sure? And I would say, yes, I'm positive. Ha ha ha. Okay. So let's go ahead and put these guys into practice. Negative 6 times 7. Well, there's only one negative sign here, so that is a negative 42. Negative 24 times negative 0.5. Well, a negative times a negative is a positive, and that's 12. Or you can just say that is 12. You don't need a positive sign on there. That's totally fine. And then finally, negative 4 squared is the same thing as negative 4 times negative 4. Remember, negative times a negative is positive 4. Or, I'm sorry, it's not a 4. It's 16. That equals 16. Also, pro tip. If you ever see anything squared, squares are always positive. Oh, that's really hard to read, isn't it? Always positive. So guys, be like perfect squares. Not that you have to be perfect, but you should be positive. Haha. Alright. Now to simplify each square roots are always positive as well. So we would say that this equals, you know what, I'll go down to help you see it better. Negative, and then the square root of 25 is 5. So when we say the negative square root, it's going to be negative 5. And then here, plus or minus, this means both plus and minus. So we say it's plus or minus the square root of 2, the square root of 4, which will be 2, over the square root of 49. So plus or minus 2/7. You can totally leave your answer like that. I like to do it because it saves me some time. If you would rather say that's negative 2/7 and 2/7, and you want to like split them up like that, that's totally fine as well. They mean the same thing. There you go. Okay, so that's multiplying. Now let's work on dividing. And guess what? The rules are the same. If you have different signs, like negative, positive, positive, negative, the answer will always be, the quotient will always be negative. And similarly, if the signs are the same, so you have positive and positive, or negative and negative, the answer will always be positive. So on your note sheet, you should notice a little error. You zoom in on this guy right here, and you say, oof, right here, negative 20 divided by negative 5, positive 4. There you go. All right, finally, let's divide by 0. You ready? This is one of our favorite things. The quotient of 0 and any number, that is, if we were to look at it, it would look like this. The quotient of 0 and any number says 0 divided by anything, or 0 divided by any number, whatever it is, it will always be 0. All the time. Imagine this. Imagine that you have 0 cookies and you want to divide them among your friends. Even if you have one friend, even if you have 1,000,000 friends, if you have 0 cookies to hand out, everyone gets 0 cookies. But that's okay, at least you have friendship. However, the quotient of any real number and 0, that is any real number and 0, we're going to flip it around if you have n divided by 0 or n divided by 0, they both look the same. We don't like that. It doesn't work with our system. We don't have a definition for it. We say it is undefined. As you get into more complicated maths, there are more complicated, I can't even say it. There are more complicated answers, but for now it's undefined. We do not define it. Okay. So using these rules, let's test out our examples. First, 0 divided by a is 0, because 0 divided by anything is 0. 5 divided by 0, undefined. You literally write the word undefined. Yay. 0 divided by 5, 0. 0 divided by negative 4, 0. 0 divided by anything, literally 0. Cool. Let's put this into practice. Not the 0 stuff, but we've got our friend Pavel. He's going skydiving, and his elevation changes by negative 3,600 feet in 4 minutes after the parachute opens. What's the average change in his elevation each minute, or per minute? Okay, so we want to find the change in elevation. That's going to be feet per minute. And we know that, well, in 4 minutes, he fell negative 3,600 feet. So we want to do negative 3,600 divided by 4. That comes out to be negative 900 feet per minute. So in a complete sentence, which I'm not going to take the time to write out, we would say, Pavel averages a fall of 900 feet every minute. There you go. Don't hit the ground too hard. Also, I have a good skydiving joke. If you remember to ask me, you might get extra credit. It's funny. I think it's hilarious. It's funnier than that smiley face, which is super funny looking. Oh well. Okay. Finally, the inverse property of multiplication says that for every non-zero real number, so as long as a is not 0, there is what's called a we need a fun color for this, blue. There is a multiplicative, so look at this word multiplication and copy it. Multiplication, but instead of because this is not a noun, you do multiplicative, because it's an adjective. A multiplicative inverse. Inverse is kind of like the opposite, but not quite. And we say the multiplicative inverse is 1 over a. So if you have a, its multiplicative inverse is 1 over a. And then when you multiply them together, you get that a times 1 over a equals 1. I'll do a bunch of examples. In fact, I'll do 3 examples right here. Okay, cool. So multiplicative inverse is hard to say. We also call it its reciprocal. I like to say reciprocal a lot more than multiplicative inverse. Just know they mean the same thing. Okay. And the reason this works is because if you have some number, a, and you multiply times 1 divided by a, that's the same thing as a over 1 times 1 over a, and then our a's are going to reduce. So this reduces with this. You just get 1, and then 1 times 1 on the top is 1, and then 1 times 1 on the bottom is 1, and 1 divided by 1 is 1, and wow, I've said 1 like way too many times. But yes, they're always 1. So to find the multiplicative inverse of each number, I'm going to tell you the shortcut right away. Flip it over. So the multiplicative inverse of negative 6 over 1 is negative 1 over 6. Ta-da! We flipped it over. And this is because negative 6 times negative 1/6 equals 1. That's why it works. The multiplicative inverse of 5/3 is, flip it over, 3/5. Because 5/3 times 3/5 multiply across 15 over 15. And 15 over 15 is 1. All right. My friend's mom says, all righta. So that's exciting. And then finally, the multiplicative inverse of m over n, flip it over, is n over m. Because when you multiply them together, m over n times n over m equals m times n over n times m. And now we can reduce them out. They need an even lighter gray. Okay, m over m reduces to 1. N over n reduces to 1. And, oh, this is the wrong gray still. Hold on, guys. Okay, here we go. 1 times 1 is 1. 1 times 1 is 1. 1 divided by 1 is 1. And I did the 1 thing again where I say 1 a lot. Oh, man, hey. I hope that saved my progress. Well, you got all the important information in this video. Except, oh no, it didn't. It didn't save the last problem. So, in case you missed it, it's n over m. There. Oh, no, it's not equal to. Oh, it's not equal to. That was so bad of me. Oh, there you go. Okay. So I'm going to show you a cute little shortcut real quick of our lesson for the whole day. I'll put it right here. Here's a table that my teacher taught me when I took Algebra 1. Okay, if we're multiplying and dividing, then remember this. I should do this in colors. A positive times a positive is a positive. A positive times a negative is a negative. A negative times a positive is a negative. And a negative times a negative is a positive. So here you go. Here's our key idea of the day. Know it, love it, memorize it. It looks like Christmas, so it must be good. I hope you have a wonderful day.